Hello, students. All right, this is Mrs. Epperson. I'm going to talk to y'all today about equations that are fractions. Now, first off, I'm going to talk about the fun little axiom that we have, this property of algebra. It's called the multiplication property of equality. What that says is the multiplication property says that if I have A is equal to B, okay, I can take C, or a value C, and I can multiply, and this can become A times C is equal to B, whoops, sorry about that, is equal to B times C. I can multiply both sides of this equation, and it will still be true, okay? For example, let's take, for example, we have 2x plus 3, and well, let's say we have that equal to 9. All right. This isn't too bad. I know if I subtract 3 from both sides of my equation, that's going to become a 0 pair, and then I'm going to be left with 2x is equal to 9 minus 3 will give us 6, all right? Then we're going to divide both sides by 2. This becomes 1, so then I'm left with just x. And I know 6 divided by 2 is 3. Okay, we know that using that equation is equal to, x is equal to 3. Well, with the property of multiplicative property of equality says that I can take that same equation, 2x plus 3 is equal to 9, and I can multiply the whole equation, or rather both sides, both expressions, by any number, any value. Let's say, I'm going to pick a random number, let's say 5. Okay, we're going to use 5. I'm just going to make it easier for me. I'm going to say 2. I'm going to multiply both sides of my equation by 2. Now, the distributive property says that I need to distribute this 2 to both terms inside my parentheses, because I have parentheses there. Okay? So now this is going to become 4x plus 6 is equal to 9 times 2 will give us 18. Right? Now I'm going to subtract 6 from both sides. That's going to give me 4x is equal to 8 minus 6 will give us 12. And we're going to divide both sides by 4. X is equal to 3. So we know that it works. It's the same answer. These are equivalent statements. Okay? Now, the reason that this idea, this concept is important is because if I take something, let's say, that's a fraction, okay? And let's say, for example, my problem, let's write this down, and let me go, hold on. And let's say my problem is something like x over 3 plus, let's say, 2, and let's say this is equal to 4/9, okay? Now, I've got fractions. Yes, we know we can deal with the fractions. I can subtract 2 from both sides. Then, because we want to, our goal is to find out the value for x, okay? The value right there. That's our goal. That's what we want to isolate and get by itself, okay? Well, I can get rid of my fraction. I want to get rid of these fractions. I have a 3, and technically I have a 1. That's a 2 over 1. And then I have a 9, okay? Now, I'm going to look at all 3 of those denominators. I'm going to look at 3, and I'm going to look at 1, and I'm going to look at 9, okay? I know 3 won't go into 1, but I do know that 3 will go into 9, okay? I also know that 9 won't go into 3. So I don't want to multiply my equation by 3. I want to multiply it by something that the denominators, all 3 denominators, will divide evenly into, okay? So I'm going to multiply my equation by 9. Now, I'm going to show you what happens. I essentially say, stop, my cat is trying to play with me, 9 times x over 3 plus 9 times 2 over 1 is equal to 4 times 9 over 9. Okay? Now, the reason that this is important, I'm going to talk about 9. Let's talk about 9 times x over 3. Okay? This little times here, that means something special. This is equivalent of me saying 9 times x over 3. It's also equivalent to me saying 9 over 3 times x. All 3 of those are equivalent statements for that expression. Okay? Now, the reason that is important is because 3 will go into 9 3 times. So then that becomes 3. 1 goes into 9 9 times. So 9 doesn't reduce. 9 won't go into 4, but 9 will go into 9 1 time. So that cancels it out and becomes 1. So now I'm just left with 3. So that's this number here, 3. Whoops, didn't mean to delete that. Meant to highlight that. That means that number there, 3 times x, which will leave me with 3x, plus 9 times 2, which is 18, is equal to 4. Okay, now I'm going to subtract 18 from both sides. All right, that's going to leave me with 3x. 4 minus 18 will give me negative 14. I'm going to divide both sides by 3, and that becomes 1. So then I'm left with x is equal to negative 14 over 3. Now,